of intergovernmental organizations, or what I call IGOs. Although it's mainly about international organizations and it's a lot about international relations, I hope the insight and some of the ideas resonate with you, whether it be topic of you measuring like student grade distribution or satellites or whatnot. With that, let me briefly contextualize why understanding member distribution matters so much, especially in the topic of intergovernmental organization theory, IGO theory again. So a lot of the topics and questions about intergovernmental organizations, including lifespan of IGOs, design aspects, when the states get a chance to have a veto power, their flexibility, IGO performance, all of these are ultimately shaped by membership composition, like who the members are. But then the last part about membership composition can mean a lot of different things, right? It can be about power asymmetry, economic asymmetry, military capacities, heterogeneity in terms of economy, political regimes, and so on. Among many different features of membership distribution, I am going to focus on central tendency of membership distribution. So conventional approach to measure central tendency has been using sample arithmetic mean of member states' democracy scores for a given IGO year. So you just you sum all of the member states' democracy scores and you divide it by the number of member states in a given IGO. And your reaction might be, there has to be something better than that. That's exactly where this project started, and that was the motivation behind the bigger project of understanding membership distribution of intergovernmental organizations. So to unpack the question of how can we better estimate central tendency, we have to answer 3 questions in a sequence. We do have a gut feeling that sample mean is not really the best we got, right? But we have to answer, why is sample mean insufficient? And if so, why not? We have to come up with ideas and hypotheses on why sample mean can be insufficient, especially given the substantive question that we have in hand. Also, we have to quantify and operationalize the insufficiency itself. How are we going to convince people that sample mean is insufficient, without just sharing the intuitive hypothesis? So I'm going to address all of these questions one by one, and I hope I can convince you that sample mean is not really sufficient to measure central tendency. And I hope you can pick up some of the intuitions and ideas incorporated in the project that resonate with your own research and your own research projects. So oftentimes sample mean is a pretty parsimonious and strong measurement for normally distributed data. So the first question that we have to answer is, what does our data, my data in hand actually look like, right? So just to give you a picture of data that I use, it's an international organization country year data set. So we have a list of international organizations that have ever existed in global governance history in a given year. And each IGO has a list of member states, right? Like not just observers or not just participants, but real member states. And each member state, member country, has its own democracy score. And democracy scores can change from year to year. And member states can also change from year to year depending on IGO. So it's structured in IGO country year level, and each country gets a democracy score that ranges between 0 and 1. And 0 and 1, not inclusive. It never touches 0 and 1. The higher the democracy score is, the more democratic a country is. I am showing you a snapshot of 4 prominent international organizations that you might have heard of, and this is a distribution of member states' democracy scores. For example, if you look at the upper left panel, you're seeing Association of Southeast Asian Nations, ASEAN, and it's roughly composed of non-democracies, highly concentrated around 0 to 0.5. And we also have Gulf Cooperation Council, which shows you a more salient distribution centered around non-democracies on the left side of the x-axis. On the other hand, we also have the United Nations, which has some chunk of non-democracies on the left side, and also a little bit of democracies on the right side. Just looking at this cursory snapshot of data, this is definitely not normal distribution. And we're getting closer to the intuition that simple mean might not be doing a great job, especially capturing central tendency when data actually looks like this. And looking at the data, it looks like it's roughly following beta distribution. And this is where, I don't know, mathematical probability class can pace you off, but it roughly follows beta distribution, knowing the data that we see, and also seeing that democracy score ranges between 0 and 1, not including the end of the spectrum. The cool thing about beta distribution is that it allows for flexibility. It allows room to estimate skewness, as you see on the shape quadrant. It also accommodates unimodal. It also accommodates bimodal distribution, unlike normal distribution omit. And this is one of the probability distribution family. And the shape is determined by two shape parameters, alpha and beta. And depending on the shape parameters, IGO will follow one of the shape quadrants that are shown on the slide. We have autocracy skewed IGOs, democracy skewed IGOs, unimodal IGOs. We also have U-shaped IGOs. U-shaped IGOs or polarized IGOs might be less intuitive, but there were a lot of these cases during the Cold War where bloc of democracies had to cooperate with non-democracies to create a shield against the growing clout of communism. So there are a lot of different type of IGOs that have existed in our IR history that follows one of the four shape quadrants. Now that we know the sample mean isn't doing a great job, and we also have an intuition now that democracy score is roughly following beta distribution, our next task is to quantify, how bad the problem is and to what extent beta parameters can recover some of the information missing out from normal distribution, sample mean. To do that, we created a simulated data set from beta distribution. And this time, because I generated the fake data set, I know the true data generation processes. So in this case, beta mean equals true mean equals theoretical mean, which might not be the case if you're using already created data set. Knowing the true mean, because I generated the data set, knowing the true mean, we're now comparing how off the sample means are from the true mean that I have. So across all the simulation, we are now going to compare the deviation between the sample mean and beta mean. The y-axis that you're seeing refers to alpha to beta ratio, which increases when the distribution gets skewed. And the x-axis represents the sample size of member states of IGOs. And the red color represents when the points where the deviation gets more significant. Again, the deviation between sample mean and the true beta mean, the answer mean. And there are two implications or takeaways that I want to highlight from the plot. The first is along the y-axis. The more skewed the IGO gets, the worse job the sample mean is doing estimating the true theoretical mean. And on the y-axis, it also becomes a bigger problem when you're dealing with IGOs with small sample sizes. And that's a big problem, at least in terms of answering the substantive questions, because oftentimes we as in IR scholars are interested in studying regional small international organizations and IGOs that are skewed to the left and right, rather than something as the United Nations or World Trade Organization. So the deviation between sample mean and beta mean can be a huge missing point, at least in terms of answering substantive questions that revolve around skewed IGOs and small regional IGOs. We also make another claim that sample mean would do a bad job in terms of dealing with sampling variability. So by sampling variability, I mean the very idea that the data that we have in hand is just one manifestation of many different possibilities that could have happened in the world. So imagine a country's democracy score was surveyed by a different set of experts. And we might end up having different democracy scores, not because of observed explanations, but due to unobserved randomness around a set of survey experts that were surveying the countries, that were evaluating countries' democracy score. And we want to accommodate that randomness around the evaluations, right? And the claim that I'm making here is that sample mean is not robust against those sampling variability. And that's a claim. And I have to tell you why that's bigger problem for sample mean compared to beta mean. The real challenge here is that sampling variability is essentially about the data that we never have in hand, right? It's about the world that we never get to observe. But then how are we going to compare sensitivity and robustness against all these different hypothetical worlds, right? So the idea to resolve that challenge was the idea that even if one small thing took a different route for measuring South Korean democracy in 2006, for example, it should look something similar to South Korea democracy score in the near past or near future. By comparing a country's democracy score from its own time span, we are making some reasonable bounds around how random the country's democracy score could be, but at the same time accommodating for unobserved randomness and noises around democracy scores. With that intuition and idea in mind, what we did was the following steps. So for each country, we resampled its candidate democracy scores that could have happened, but we never got to observe that. So we resampled each country's democracy score from its near future and the past within 2-year time window, and we aggregated that at the IGO level. So for each IGO, we are getting new set of sample mean and beta mean estimators, not from the observed democracy, but from hypothetical candidates. So remember, we are recomputing estimators, plural, because we have to compare sample mean and beta mean. So for each simulation, we now get to see how skittish those means are vis-a-vis all the sampling variability and hypothetical data sets that we have. And the plot shows you the result of that simulation. And I want you to ignore the color for now and just focus on where the dots are located at. The y-axis reflects standard deviation of sample mean minus that of beta mean. So that means all the dots that sit above the zero horizontal line reflects the fact that sample mean was more skittish. It was fluctuating around all these hypothetical scenarios compared to beta mean. In other words, beta mean was more robust against sampling variability. It was more robust against noises, unobserved noises around democracy score compared to sample mean. That's the first implication or the takeaway from the plot. And now I want you to focus on the color differences. This is a point of clarification here is that the color distinction is not about sampling variability. It's a bonus finding that we came across while running the simulations. So forget about sampling variability for now. This is more about bonus of using beta mean. So the points represented in green color reflect estimators that were shrinking towards the center of distribution. It was ranging from 0 to 1, so the center being 0.5. And the fact that beta means were shrinking towards the center means that if you are ever using beta mean as your independent variable to predict something else, your beta mean is going to vary so little, it's going to be very conservative in giving you the information about your y variable. So if you're using beta mean as a predictor for something else, it's going to be a conservative measurement compared to the sample mean. But again, that's more of a bonus rather than a direct piece of evidence that I am convincing you regarding sampling variability. So I have made 2 claims so far. Number 1, sample mean doesn't capture the beta distributed data set. And number 2, sample mean is less robust against sampling variability. And those 2 issues are very significant in terms of us studying democracies, because we do want to accommodate some of the randomness around democracy measurements, and we do want to understand flexible distributions especially skewed IGOs and polarized IGOs. We know that beta mean is doing a much better job than sample mean at this point. But then the question becomes, how are we going to estimate beta shape parameters? We know that we have to use beta mean, and I hope that I've convinced you that is the case. But there are two ways of estimating beta shape parameters, right? And we can take maximum likelihood approach, but we took a Bayesian estimation approach, and let me explain the rationales behind it. So remember when we were applying beta distribution to study IGOs, it unlocked a lot of different perks. We were suddenly having access to quadrant shape, and we kind of want to assign IGOs to one of those shape quadrants, right? It's informative. We want to study IGOs that are skewed, unimodal polarized. But then if you're relying on one simple estimate, then you're only making a deterministic claim saying that World Trade Organization in 2007 is U-shaped. But there's a lot of overconfidence baked into that. And we do want to accommodate uncertainties, and we do want to make those uncertainties transparent by taking probabilistic approach. And that's where Bayesian approach can be helpful. So for each IGO year, Bayesian estimates will give you different number, 3,000 different posterior draws. You are getting 3,000 different sets of posterior alpha and beta shape parameter estimates. And depending on each round of evaluation coming from posterior draw, it will tell you, IGO is following unimodal. If both alpha and beta shape parameters are, smaller than one, it's telling you it's U-shaped. And you're getting 3,000 different evaluations or judgments from posterior draws. And we use that posterior draws to calculate the probability of that IGO falling into one of those shape quadrants. So simply, by counting up the ratio of shape quadrants appearing out of 3,000 samples, we get the probability. Say, for example, if you're looking at ASEAN 2015, we'll get 3,000 different draws, and 300 of those draws were estimating alpha and beta parameters to be greater than 1, right? In that case, we get to say ASEAN 2015 has a probability of taking unimodal shape with the probability of, did I say 300? 0.1. And, that's different than saying it's taking a unimodal form with a deterministic statement. So the ultimate information, if we sum up all these approaches together, we are now making a claim that IGO in a given year has a probability of having one of the 4 shape quadrants following beta distribution. And this is a huge step from where we started, which is based on sample mean, it's autocracy skewed or democracy skewed, simply because it crosses the threshold of 0.5. This is what the data actually looks like if you apply the framework to the given data in hand. And if you look at the upper left panel, this is based on IGOs who had the highest probabilities for being autocracy skewed. So even those IGOs whose winning probabilities was autocracy skewed IGOs, there were a lot of losing probabilities. For example, the average probability for IGOs that had the highest probability of being autocracy skewed are still around 0.6, which means there are remaining posterior draws that were telling the story from the data that it's U-shaped and it can be unimodal shape. And the same type of inconsistency or same type of uncertainty is present across all different shapes. And this plot alone also shows why taking a deterministic approach can grossly undermine or grossly look over the uncertainty that's lingering when you're making claim about IGO's distributional shapes. And another takeaway from this data set is that not all IGOs are democracy skewed, because if you often talk about international organizations, we tend to think about European Union or like those of liberal democracies, but there are a lot of other type of international organizations that are skewed towards a group of autocracies, and those IGOs can be studied with greater depth with having the probability of those shape parameters. So we have unlocked a lot of different perks by taking the new framework. And now I'm going to showcase how it applies to answer the substantive question of my interest of international organization. There are two big theories in the connection between international organization and domestic politics. It's called democracy from above and autocracy from above. The theory is just simple. If a country is a member of international organizations that are skewed towards democracies, then that country is more likely to democratize. And the same applies to autocracy from above. If autocrats are member states of clubs of autocrats, then that autocrats are more likely to survive longer in their dictatorship regime. That's a simple theory, but I'm going to show you how I'm going to test that substantive question using the framework that I've shown you earlier. But before that, I have to take a pause here and I have to make sure that we're on the same levels of analysis, because otherwise this might sound pretty circular. Going back to the ground zero, we started from country's democracy score, right? And knowing the member states' country democracy scores, we constructed new variables at the IGO level. We can now say IGO is skewed to autocracies and democracies. But now we're coming down the ladder from IGO level to country level, because now we're interested in country level's exposure to autocracy skewed and democracy skewed IGOs. So we're taking a step up and we're taking a step back at the country level. But that's the substantive interest of the research question. I'm not interested in unimodal IGOs. I'm not interested in polarized IGOs simply because for theory's sake. And I'm only interested in measuring to what extent a country is exposed to autocracy skewed IGO and democracy skewed IGO. The way I measure that is simple because I already have all the probabilities of IGOs. For each IGO, I simply averaged out IGO's probability for taking AIGO shape and DIGO shape that a country belongs to. So it's similar to weighted average. If a country is a member of IGOs that are clearly autocracy skewed, then it's very likely it's going to have a higher exposure score. And if a country is member of like a mixed bag of autocracies and democracies, then exposure score will be pretty low and mixed. Leveraging the probabilities that I already have, I have constructed new variables of exposure to AIGO and DIGO, autocracy skewed and democracy skewed IGOs. Now I have made some decisions around modeling. Remember, we are interested in understanding what happens to a country's democracy score if it gets IVs from democracy and autocracy IGOs, right? So the main dependent variable is country's democracy score the next year, because it takes some time for IGO level policies to kick in and affect domestic political institutions. And our key predictors are exposure to these two types of IGOs. And I also included a battery of confounders that might affect both the X and Y variable. With that modeling, I will report the results, but I report the results in two levels. First, I will convince you why the earlier model that I set up makes sense. And only after I convince you that models are doing a pretty good job, we can move on to interpreting the substantive parts of the model. I'm not sure if you are familiar with the information criteria for Bayesian regression, but basically the plot is showing you how much of our model can predict the observed data set simply based on the model. So the dark gray, navy line represents the real data set that I have. And the blue line or sky blue lines represent posterior draws from each of the trial from the modeling. And our model did a pretty good job in terms of recovering the two modes near the end of the spectrum. It also kind of recovered a little hump around the 0.5 area. So we also checked other information criteria through cross validations, like leave one out and we tried it with other samples, and our model was pretty robust against other modeling decisions. All this is to say that, we have good reason to trust that AIGO and DIGO exposure can be a good explanatory variable for understanding countries' democracy score. And let me visualize what that means in terms of substantive terms. So the plot that I have on the slide is a counterfactual scenarios. Everything else stays the same except for a country's exposure to clubs of autocrats, clubs of democracies. And this particular plot shows you the counterfactual if you crank up the exposure to autocracy-skewed IGOs. Everything else stays the same, but a country is now exposed to autocratic IGOs to the maximum level possible. And the orange line represents the scenario when it's increased to the max. And all of the countries showed a great retreat in their democracy when they were in the world where they're exposed to AIGO to the greatest degree. And the result gets pretty more dramatic when we look at counterfactual regarding the democratic IGOs. Again, if you maximize the exposure to democratic IGOs, all of the countries' democracies suddenly jump significantly. And even if the number sounds pretty marginal, remember it's country's democracy score, and we are talking about how IGOs impacts can trickle down to domestic level. And even the 0.01 level implication can mean a huge change on the ground when it comes to electoral competition and media representation. So again, the orange line represents a maximum scenario, maximum hypothetical scenario, and it shows a stronger effect when a country is exposed to democratic skewed IGOs. So democracy from above works, autocracy from above also works. I hope that, some of the intuitions resonated with you, but there are just a couple takeaways that I like to highlight before I conclude. First, when you think about some group level composition, again, like student grades or whatnot, it's often about distribution, not about a specific mean or a point estimate. And simply by looking at the data set and wondering what the probability distribution it follows unlocks a lot of information. In my case, changing from normal distribution to beta distribution allowed me to recover information about skewness, polarization, and all these interesting things that IR scholars care about. And on a substantive sense, I hope the talk about international organization was interesting. I love talking about IGOs, but substantively, IGO environment can affect countries' democratic trajectories in both democratic and autocratic way.